You people have done differential equations already, so it will be just a revision. Watch out carefully for it. Differential equations. Differential equations are the equations which involve three things: dependent variable, independent variable, and the differential coefficient. So any equation which involves these three things, that is equation involving dependent variable, that is y, independent variable, that is x, and the differential coefficient. Differential coefficient, that is dy upon dx, d2y upon dx square, and so on. So any equation which involves these three things is differential equation, or in short, we call it DE. For example, dy by dx plus y square equal to x. It has dependent variable, it has independent variable, their meanings can change, and the differential coefficient as well for differential equation. Or it can be in the form of d2y by dx square plus dy upon dx plus y is equal to 0. Another example of differential equation. Or it can be in the form of d3y by dx cube to the power 4 plus d2y by dx square to the power 7 equal to, say, just x. One last example, say it is d2y by dx square plus sine dy upon dx is equal to ax. So all these equations involve dependent variable, independent variable, and the differential coefficient. So these equations are known as differential equations. Now there are two things that we need to understand about differential equation, which is order and degree. By order, we mean highest number of times the dependent variable has been differentiated. The highest number of times dependent variable has been differentiated. By degree, we mean the power of the highest order derivative after removing all fractional और नेगेटिव पार्ट्स. फ्रैक्शनल या नेगेटिव पार्ट्स को रिमूव करने के बाद जो भी पावर होगी हाईएस्ट ऑर्डर डेरिवेटिव की, दैट विल बी द डिग्री. नाउ लुक, over here it has been differentiated only once, so its order is 1. Since there is no other term containing differential coefficient, so we'll check the power of this only. Its power is 1, so its degree will also be 1, right? Now it has been differentiated twice, right? So order of this will be 2. And what about degree? 1. Right now it is 1. If I make this as cube, now what will be the degree? Now what will be the degree? कोई फर्क नहीं पड़ेगा. Exactly. Very good. I'm proud of you. कोई फर्क नहीं पड़ेगा because we write that is degree is the power of the highest order derivative. Higher order derivative तो यहाँ पर ये है, तो इसकी पावर अगर चेंज होगी तो फर्क पड़ेगा. What will be the order? 2 or 3? And what about degree? 7 तो नहीं? What about order? 2. What about degree? किस पे? So sorry. Degree 4. Over here the degree is not defined. Now what is the reason why degree is not defined in this particular question? If any, I repeat, if any differential coefficient is the angle of any t ratio, then the degree of differential equation is not defined, right? So यहाँ पर भी एक चीज हम याद रखेंगे. If any differential coefficient is the argument of any t ratio, then degree is not defined. You'll have 1 mark question based on this, and that's for sure. Each mark is important, right? जल्दी से इसको note करो. Verification based question. That is where we need to verify that whether the given solution is right or not. So for verification based questions, they will give you 2 equations. One SE and one D. SE and DE will be given. What is SE? Simple equation. And what is DE? Differential equation. So that is, we'll have to differentiate the simple equation as many times as is the order of differential equation. और उसको फिर जैसे हम differentiation के proving questions करते थे, it is exactly the same. देखो आप, if y is equal to e to the power x, show that d2y by dx square minus dy upon dx is equal to 0. Y की value already given है, and we need to show that d2y by dx square minus dy upon dx is equal to 0. Now here the order is 2. So how many times will we differentiate this? 2 times. So what will be the value of dy upon dx? E to the power x. What will be the value of d2y upon dx square? E to the power x. Now taking LHS. LHS is d2y upon dx square minus dy upon dx. So this will be e to the power x minus e to the power x equal to 0 equal to RHS. This is exactly what we do for verification based questions. We differentiate the simple equation as many times as is the order of the differential equation, and then we follow what we have done in the proving questions of differentiation, right? Manasvi, am I clear with it? ये simple equation हमें given है और वो equation हमें prove करनी है. So we'll differentiate this, differentiating with respect to x. Differential of, that is xy. So x as it is, differential of y, y1. Y as it is, differential of x, 1. A as it is, differential of e to the power x, e to the power x. B as it is, differential of e to the power x, e to the power minus x into minus 1 plus 2. Now differentiating again with respect to x. फिर से product rule. X as it is, y1 का differential, y2. y1 as it is, x का differential, 1. Plus y का differential, y1. Equal to, this will be a e to the power x plus b e raised to the power minus x plus 2. Now, in place of this, what can we write? फिर से बोलो. एक बार फिर से बोलो. Plus 2. Hence proof. Automatically आ जाएगा. हाँ जी. क्या हुआ ये सब कुछ आपने? This is solution of D. इसको एक सिंगल से फ्रेज से हम समझ सकते हैं. Solution of DE is obtaining SE from D. This is solution. That is differential equation given होगी और उससे हमें simple equation obtain करनी है. As simple as this, और सच में simple है. Basically हमें differential coefficients को remove करना होगा रजत. और अगर हमें differential coefficient को, that is if we need to get rid of dy upon dx, if we need to get rid of differential, what will we have to use? Integration, because to get rid of differentiation, it is antiderivative, which is integral. So इसमें 3 forms है total हमारे syllabus में. We'll be doing the first form today, which is variable separable form. नाम से ही सब कुछ clear है. Separate the variables and integrate. बस variables को separate कर दो दोनों side, integrate कर दो. For example, dy upon dx is equal to say 1 plus x upon say x minus 3. ऐसे upon y minus 3. ऐसे collect all the terms of y together, all the terms of x together. So this will be y minus 3 of whole dy equal to x plus 1 of whole dx. When we separate the variables, remember to keep dy and dx in the numerator. ऐसा नहीं होना चाहिए y minus 1 जैसे यहाँ पर हो y minus 3 upon dy. dy and dx should always be in the numerator. Once the variables are being separated, simply integrate both the sides. Simple integral. सिंपल इंटीग्रल, सच में सिंपल इंटीग्रल, इंटीग्रल ऑफ y स्क्वायर अपॉन 2, इंटीग्रल ऑफ 3 माइनस 3y। हमने c यहाँ पर नहीं लगाया क्योंकि भी यहाँ पर भी इंटीग्रेट करना है। इंटीग्रल ऑफ x स्क्वायर अपॉन 2, इंटीग्रल ऑफ 1 x प्लस 3। The differential equations have got two types of solution: general solution and particular solution. If we leave it in terms of c, it is general solution. If we find the value of c also, it is particular solution. For example, अगर हमें ऐसे दे रखा हो y0 equal to 1, y0 equal to 1 means when the value of x is 0, the value of y is 1. Am I clear with it? इसको बोलते हैं boundary value. When the value of x is 0, the value of y is 1. तो यहाँ पर ये वैल्यू पुट अप कर लेते हैं, y की जगह 1, सो 1 अपॉन 2 माइनस 3, x की जगह 0 प्लस c, तो c की वैल्यू कितनी हो जाएगी माइनस 5 अपॉन 2। बस ये वाली वैल्यू आप यहाँ पर पुट अप कर दो, तो दिस इक्वेशन विल बिकम y स्क्वायर अपॉन 2 माइनस 3y is equal to x square upon 2 plus x minus 5 upon 2. So this solution is the general solution and this solution is the, बस यही करना है कंप्लीट डिफरेंशियल इक्वेशन में, नथिंग एल्स। दिस इज द लास्ट कांसेप्ट ऑफ डी। और इसके दो मेथड्स और हैं, बट करना यही है, बस सॉल्व करना है। इज इट डिफिकल्ट? द बेस्ट वे टू रिवाइज इंटीग्रेशन इज टू डू डिफरेंशियल इक्वेशन। इंटीग्रेशन ऑटोमेटिकली रिवाइज होती चली जाएगी। प्लीज बी अटेंटिव, बी रेगुलर। हाँ, अगर कोई फर्स्ट टाइम करो तो भी इसको समझ में आ जाएगा।